In this video, we are going to do revision exercise 7, and that will be coordinate geometry and linear programming. You will find this on page 341 in the Namibia Ordinary Level textbook, Y equals mx plus c to success mathematics textbook. Okay, let's start with the exercise. Coordinate geometry and linear programming. Now, if I say the distance AB is 7 units, okay, where is A and B? Okay, can I just show you here? It means that that is going to be 7. Okay, write down the equation of the line through B, okay, through B, which is parallel to this. Okay, we will come now to the distance. Now, can I just want to go to the summary. Because in coordinate geometry, it's actually the way you approach the sums, and there is theory, but very, very important is that you must memorize these formulas. Okay, so if you want to find the distance between two lines, it is actually coming from Pythagoras Theorem. So you take the difference in x and you square, plus the difference in y and you square. Now that was AB was square, so to get rid of that square, I take the square root. And you don't take plus minus because length can only be positive. If you get the midpoint, I take my x values, I add it up, I divide 2. I take my y values, I add it up, I divide 2. And then the gradient, okay, the gradient is, I mentioned it in a previous video, it's the difference in y divided by the difference in x. And now, if straight lines are parallel, this is very important, their gradients are equal. So that will be, say, y equals mx plus c, right, the straight lines. This is the equation of a straight line. So that values will be equal. And if they are perpendicular to each other, they are reciprocal fractions with opposite signs. So if the one is positive 2, then the other one will be negative a half. If the one is negative a quarter, the other one will be positive 4. Okay, and that, just keep this in mind. Let's go back. So, write down the equation of the line through B. So, there is B. Can I just show you? There is B. Through B, which is parallel. Now, what did we say? If gradients are parallel, we're just going to write it here. It's number A. If gradients, okay, let's just write it like this. Parallel. Then their gradients will be equal. Okay, so basically, I'm just going to use this gradient. And what is this gradient? The gradient is 2. So I'm going to say, okay, if the lines are parallel, then I already know the value of m will be 2. Okay, now it's going through B. But now the problem is I must quickly go and see what information do I have. I just write down the equation which is parallel to this. I'm seeing the distance OA. Let's just say, how do I know that this distance is 3? I know that this distance, can I just show you here? This distance is 3. I see it from there. It cuts there at 3. Okay. Now, if I'm telling you this is 7, so what will this part then be? That part will be 7 minus 3, so that will be equal to 4. So I already know, I'm trying to find this coordinate point. So it takes a little bit of, you must take the information and start looking at the information, and from that information start filling in a few things. So I know that it cuts there at 3. I know that this distance is 7. So 3 from 7 is 4. So I know that this point, and it's negative, and the x value is 0 and the y value is negative 4. So I know that point B is going to be 0 and negative 4. And I'm going to do now not the AS-Level method. I'm just going to do the method which I usually do on this level. So I'm just going to first write down my straight line equation. also the names of the books. Okay, so then I start going to fill in. I know that this is now x1, y1, and there's my m. So in the place of, okay, I just have 1 point, so it's just y. So I'm just going to substitute there a 4, a negative 4. And I substitute a 2, and what's the value of x? 0 plus c. So therefore, the value of c, what is the value of c? The value of c is negative 4. And if I substitute both in, this one as well as this one, so I'm getting that therefore y is equal to 2x minus 4. And that is my final. So write on the equation through B, which is parallel. So the parallel, if it was perpendicular, I would have said it's negative a half. So this is almost just like my helpline. It's just helping me to get that gradient. Okay, let's go to number B. Find the coordinate of the point C where the lines BC crosses the y-axis. Okay, now just be careful. You were just finding it through B, but if I'm just seeing where this line, yes, you were finding this line through B, which is parallel to that one. So I know that this line, and I just was cleaning it, but it was y is equal to 2x minus 4. That is because it's parallel. It shows you in the sketch. And it's going through point B. If I must find C, and I like this method because I'm going to use it also in linear programming. If I want to see where a line cuts the, the x-axis, I make y is equal to 0. So take your equation. So it's y is equal to 2x minus 4. And in the place of y, put a 0. And now find the value of x. Take it over. Divide 2. So x will be equal to 2. So therefore, the value of C, I know it's cutting there at 2, but that's the x value. And the y value, what will be the y value? 0. And that will then be my point C. Okay, that's coordinate geometry. Now I'm going on. Now this is going to linear programming. Can I just give you the pages where if you want to revise? In your textbook, you can go to, in your y equals mx+c textbook, you can go to page 300 to 316. Just go through that blocks and just refresh your memories on coordinate geometry. But this, using a scale, it draw the lines, label, this is linear programming. Because as soon as I see inequality signs and it's talking about graphs, I know it's linear programming. And this, if you want to revise it, and I will maybe reflect a little bit later to it, but you will find that on page 319, especially that lines, to page 324. There you will find that. Okay, but let's start. Drawing the lines is not so difficult. I will show you now, and also the shading. So use a scale of 1 to draw it from, so I think we're going to just get a grid. There's my grid. And then I'm just going to draw that lines. So if I'm drawing that lines, I'm just on that grid. It looks like it's, say, 1 in 1, draw axis from 0 to 8. So both of them will be 0 to 8. Linear programming is always just positive values. So most of the time, we just work in the first quadrant. Oh, ruler. Let's make it white. Okay. I think I'm going to keep it like this. I think it can even be smaller. Again, my ruler. Okay. And then it's, oh, let's just get that pen correct. And it's 0, and it's 1, 2, 3, 4, 5, 6, 7, 8. And this, they said x-axis. Okay, and this is 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And this is my y-axis. Okay, let's start with the lines. So if I move it a little bit up, I'm going to first draw the easy one. So they say draw the lines. Yes, yeah, I start with the easy one. That's nice. If it's only having a y or an x, now I like using this word. If it's only having a y, it cuts the y-axis at 2. It don't cuts the x-axis, it cuts the y-axis at 2. It's solid lines. It seems to me it's all solid. If there was not equal signs, then it will be a broken line. But in this case, it's all solid lines. So there is the line y equals 2. And this is the line y is equal to 2. Okay. So this one I did. Now, this is very easy, but I'm going to show it to you. If there's an x and a y, and I will then tell you something. So if it's x plus y equals 6, if it cuts the x-axis, always use this method. Make y 0. And if it cuts the y-axis, I'll tell you now something, make x 0. So in this case, cuts the x, I make y 0. So x will be 6. This case, I make x 0 and y will be 6. So it will cut there at 6 and at 6. But can I tell you something? Because they like doing it in linear programming. This is the thing I wanted to tell you. If you have 1x plus 1y and you just have a 6 there, then it cuts at 6, 6. If you have x plus y is equal 7, then it cuts at 7, 7. Okay, and they like to put that as one of the inequalities. So that was easy. I just take my ruler, it's a straight line, I just put it there. Okay, and I give it a name, like naming it. So it's x, or first the x plus y, and that will be equal to 6. Okay, now the next one. Okay. Y. Now, this is, I'm so glad they gave you this one. Because this one, if there's not a value of c, if the value of c is 0, then really you cannot say cuts the x-axis cuts, because it's going through the origin. It's just how steep it is. Is it like this? Is it like this? Or is it like this? Then don't do that. Cut x-axis, cut y-axis. Make a table. Always. If you see the value is 0, and I don't want to make such an ugly table. Okay, and I just make my table. And then this is x and this is y. Okay, and now there's just a 0. So, and then I just take the values there. 0 will be 0. And then take another one, say 4. So I think 4, I don't want to make it too big, take 2. Because 2 times 2 is 4. And if you take 4 times 2, if you substitute 8. So it will be 0, and then 2 and 4, and then 4 and 8. And then you will just take your ruler. And you will put it there. Okay, and this line will be y is equal to 2x. So please remember, if the value of 0, go for the table. The rest, you can do cut the x-axis, cut the y-axis. If it cuts the x-axis, you make y 0. If it cuts the y-axis, you make x 0. Okay. Okay, let's do that shading. Now, remember, if I say x plus y, I'm referring to which one? And can I just, x plus y was the green one. And then this one was the yellow one. Okay. And then this one is 2x. And then this one, no, this was the red one. This is the red one, okay? And then this one is the yellow one. So just make sure that you look at the correct straight line. Now, if there was not equal signs, it will be a broken line, but there is equal signs, so it's solid lines. So let's start with this one. X plus y, there, x plus y is bigger. Now, just check. This is the two sides. One on this side, one on this side. But bigger is up. Can you see that this will be smaller? This will be down. So now you check. Which one are they say? They say bigger. So this is the wanted. This is the one they describe. But I always go and I shade the unwanted. The one that's not standing there. Okay, then the next one. This is the red. This is the line y equals 2. It's referring to that line. So now I say bigger. So bigger is up. That's the wanted. But I shade the unwanted, the other side. So I'm shading this side. And then the last one. Now it's the yellow line. Now look here. It's two sides. There's a up. Can you see the up? And there's a down for smaller. Now they say smaller. So this is the wanted, the down. And I shade the unwanted, the up. And then if I say, and they say, label the region, then the region, this will be R. It's interesting. It's not always that little block there. So you must really look at your shading. So all this area, this will be the required region. Okay, very good. Because if I do a practical sum now, at least I did draw the lines and I was already showing you the shading. Then there's just 2 extra steps with practical sums. Okay, but let's move on. Let's go to the next one. Let's just make space again. Oh, no, I don't want to clean that pages. Seems to me if you stop cleaning everything. Okay. Let's do the next one. Just the lines is sometimes a little bit too much. Okay. So if I look at this one, the diagram below shows the rhombus. Okay, this is the rhombus. The coordinates of K. Now, I think it's best if you do this. Go and write it in on your sketch. So, this is K. It's -1 and -1. And the coordinates of M is 6, 6. Okay, and that's all they gave you. And then they gave you that line and they gave you that line. So, the equation they gave you of KL, there is KL. They gave you also LM. And now I'm going up. And they say, calculate the coordinates of point L. Okay. Now, if you want to find, and this is very important, if you want to find that point, can I just make it red? This is where that 2 straight lines intersect. And if I want to see where they intersect, and I have this equation, and I have this equation, I just solve them simultaneously. So I'm starting here. This is 3a. And then it's going to be 3y is equal to 4x minus 6. And it's going to be 4y. And this is again revision of algebra. That's why I like it if you know algebra. But it's not, you cannot just focus on that. You have to look at all the 12 chapters in this textbook to make sure that you know everything, the basics at least of everything. Okay, but now I'm just going to step. So I must either take the x or the y, doesn't matter. Now in this case, I think this one is a bit challenging and I like it. Because this is equation 1 and this is 2. So I must either take this to 12 or this to 12. Doesn't matter. And the signs are the same and they must be different. So that means if I multiply this one, I will multiply this one with, okay, let's see, yes, let's make the x. So I multiply with 3. But then I'm going to multiply this one with negative 4. Okay, so this one I times 3, this one I times negative 4. And then I'm doing it. So I get 9y is equal to 12x, and this one 3 times 6, so this is going to be 18, negative 18. This is going to be negative 16y is equal to negative 12x, and the negative times the negative is positive 4. And now this is what I want, because I want something to cancel out. Now I'm just going to say 9, so this will be negative 7. Okay. Negative 7y. And this one will be negative 14. And I divide negative 7 and I divide negative 7. So therefore the value of y is 2. Okay. And now I must still get the value of x. So I prefer to put it in one of the equations that was not multiplied. So substitute y is equal to 2 into equation 1. And this is what I'm going to do. I'm going to say 3y is equal to 4x minus 6. And I'm going to put a 2 there. And this I'm going to make 6. And, oh, I'm moving up a little bit. Okay, and it seems to me, let's just see if I was making a mistake there. No, it's going to work, because the 6 will come over and it will be 6 plus 6, and that's 4x. And I divide 4 and I divide 4, and the value of x, it will be equal to 3. So therefore, okay, therefore, what is that point L? Point L, what is the x value? It's 3. And what is the y value? It is 2. And I like to write it in. So let's make it just another color. There's too many red now. So make it 3 and make it 2. Okay, so there is my point L. And now I'm moving on. Now I'm just saying, okay, so if this is now L, calculate the coordinate of L, of the vertex L. Okay, now I'm just going to make space because I was notifying it already. Take this back and I can see there. Okay, and now I'm just going to say, calculate the length of a side of the rhombus. Now all the sides are the same, because a rhombus, all sides are equal. So you just need 2 points. Doesn't matter what. So let's take K and let's take L. Now what was K? K was negative 1 and negative 1. And what is my L? It's 3 and 2. And can you recall that distance that I showed you? So KL, it's Pythagoras Theorem. Now, please go, that you don't make unnecessary mistakes. I call this point 1. I call this point 2. So my formula will be the difference, okay, let's make it like this, 2 minus x1 squared plus y2 minus y1 squared. And that is going to give me, okay, it doesn't matter if you put that because it's a positive, which one in front. So x2, so it's going to be 3 minus, put that bracket, negative 1. So it's going to be 2 minus negative 1 squared. And that is going to be, okay, so it's going to be 3 plus 1, so it's going to be 4 squared, which is 16. And this is 2, so it's 3 squared, which is 9. That's so nice. And that's 25, and the square root of 25 is 5. So calculate that. So therefore, the length of a side is 5. Okay, now I go to number C. So let's just move on. Okay, so number C. They say, write down the gradient of line Kn. Now, where is Kn? Kn. Now, this is very important. A rhombus, opposite sides are parallel. So this line here, so that, do you see? I can even mark it for you, that this will be equal to this. Okay, so if you look at this, you're just going to use this. I'm first going to write that formula down. And what is that formula? So that formula is going to be, it was 3y. Now I'm first going to show you how to see the gradient. Always put it in standard form. So divide 3, divide 3, divide 3. So y is equal to 4 over 3x minus 2. So the gradient will be the value in front of x. And what is the value in front of x? It's 4 over 3. So what was the question? Write down the gradient. So therefore, you can say, was it Kn? And sometimes they do it like this. I think I'm going to just write it out. The gradient of Kn is 4 over 3 because opposite sides are parallel, and parallel lines, the gradients will be equal. Okay, now the next one. Find the equation of Kn. So I have the gradient and I have a point. I have the point K. It's going through K. So I'm taking my point K, bringing it in. There's my point K. What's my point K? -1 and -1. So this is going to be x, and this is going to be y, and this is going to be m. So if I start, I say y is equal to mx plus c. And in the place of y, it's -1. In the place of m, 4 over 3. In the place of x, -1 plus c. So it's -1. And if I bring this over, plus 4 over 3 is equal to c. And what will be the value of c? So if I subtract 3 over 3, so the value of c will just be a third. And let's just say the equation, where are we now? Find the equation of Kn. The equation of Kn will be y is equal, put in m, 4 over 3x, put in c plus a third. And that will be the equation of Kn. Okay, I must make space again. Okay, so if I look at the next one, so we are finished there. We are just at number D. And that's number 3D. Calculate the coordinates of the midpoint. Can you still remember how I said midpoint? Of Km. I have M. And that's very easy. And please go and memorize. I even want to take you there. Please go and memorize these formulas. Know how to find the distance between 2 points. Know how to find the midpoint. You just add the x divide 2, add the y divide 2. Know how to find the gradient. Know that parallel lines the gradients will be equal. Perpendicular, it will be reciprocals with different signs. Perpendicular bisector, no, it intersects there, so you will find the midpoint, then you will find the gradient, then you will substitute. Go and look, there's nice examples in the blocks. Okay, but I'm now at midpoint. So calculate the midpoint of, so I'm just going to write k. What is k? -1 and -1. What is m? 6 and 6. So this is x1, I call this 1, I call this 2, doesn't matter, you can call this 2 and this 1. So, and then if this is 2, and then to find the midpoint, it's just going to be x1 plus x2 divide 2, y1 plus y2 divide 2. And that is going to be negative 1 plus 6 divide 2. And it's negative 1 plus, it's exactly the same. So this is going to be 5 over 2. Do you agree? Divide 2, which is 2.5. And this is also 2.5. Okay. And then basically, this is my point. My coordinate point of the midpoint is 2.5 or 2.5 and 2.5. Okay. Very basic. And then I'm just going to do, I'm going to show you this method, which I do, because you can work out this equation and then solve it simultaneously, but I think it's too long, and I want to show you another method. It's too long. But I'm going to make use of this sketch, and I must just write. So it's basically, if I look at this sketch, because I want to find n, I will just work, I'm going to say basically, it's almost like, and I'm going to make it in green. Because I want to find n, I work in this triangle here. And I work in this triangle here. Okay, so I'm just finding that distance because this movement will be the same as this movement back, and this movement will be the same as that one down, and that helps me to get the point because I have these 2 points. So if I'm looking, if I go from negative 1 to 3, what is that movement? And I'm writing, it's 4. My pen. It's 4. Do you see? What's the movement up? It's going from negative 1, so it's 1, and 2, so it's 3. Do you see that? So that must be the same. That must just be also 4. Let's rather just call it 4. And that movement must also be 3. But now I just work from the point 6. It's going back. So it will be 6 minus 4. Do you agree? And that will be 2. And then it's also from 6. But now I go 3 down, so 6 minus 3, that will be 3, and that's how I get. So I work with the parallel, the opposite sides, which is parallel, and I just get that movement and exactly that same units. In this case, it was just going to this side or that side, but it must move 4 units, and left or right, and it must move 3 units up or down, and that's the easiest way. How you would do one like this. I think I'm going to do this video. I'm going to stop this video here, and I'm rather going to do the next one, which is a nice practical one. This is linear programming. I will do it in part 2 of this video.